When an AI agent incident occurs, detection is only the beginning. In this section, we'll review what happened, trace behavior across context, identify root causes, and turn those lessons into stronger controls, safer workflows, and better governance. So far, we've built the security stack in layers, understanding agent risk, constraining tools, validating inputs, defending against prompt injection, adding approvals, and creating observability. Now we use the evidence from those layers, logs, alerts, policies, and workflow context, to investigate incidents, find root causes, and improve the system before moving into multi-agent governance. Incident review for AI agents should work as a closed loop, not a one-time write-up. Detection brings signals together: alerts, anomalies, user reports, and policy violations. Triage turns those signals into facts: scope, severity, affected users, data touched, tools invoked, and actions taken. Analysis asks the deeper question: why did the agent behave unsafely, and which safeguards failed or helped? Improvement closes the loop. Policies, prompts, schemas, tests, approvals, monitoring, and governance records are updated so the same failure becomes harder to repeat in production. Triage is about reducing uncertainty fast. Start by naming the likely incident type: prompt injection, data leakage, unsafe tool use, privilege abuse, or policy bypass. Then judge severity by impact, not alarm volume. Ask what data was exposed, what tools could act, whether anything reached external systems, how users were affected, and whether regulations are involved. Containment should be immediate and proportional. Pause the agent, revoke a risky tool, disable retrieval, or require human approval. Finally, document what you know, what you assume, when it happened, and who owns the next action. Precision in an incident review comes from correlation. Start with the person or tenant, then connect the session, workflow execution, agent run, and downstream actions. Those IDs help answer scope. Was this one user, a group, an entire tenant, or everyone using that workflow? Preserve the event timeline as well: prompt, model response, tool call, approval, and final output. Also separate direct harm from indirect spread, such as contaminated shared memory or reused retrieved context. The goal is a defensible impact map, not a vague incident narrative. To understand exposure, don't stop at the final answer. Reconstruct the data path. What did the model receive from the user, uploaded files, instructions, history, or memory? What did tools fetch from documents, databases, APIs, or web search? Then determine what actually entered the model context, because retrieved data is not always exposed. From there, classify sensitivity and define the exposure state: merely accessed, included in a response, stored for later, or transmitted externally. That distinction drives compliance obligations, notification decisions, and the customer impact assessment. The conversation transcript is only part of the story. Harm often happens through tool execution. Rebuild each invocation as an event: when it happened, which tool ran, what arguments were passed, who or what called it, what permission decision allowed it, and what came back. Then trace any outbound message to email, chat, tickets, webhooks, APIs, or integrations. Ask whether inputs were validated, normalized, constrained, and logged before execution. Finally, compare the action to the intended workflow and least privilege policy. Questionable approvals are often where the incident becomes real. Next, trace the agent's path against the control layer, not just the final bad outcome. For each step, ask which policy should have applied: DLP, tool authorization, approval gates, rate limits, sandboxing, or retrieval filters. Compare expected behavior with what actually happened. Did the control block, warn, log, escalate, or simply allow? Bypasses often come from vague policy language, weak enforcement points, bad sequencing, or gaps in coverage. Missing controls matter too, because they show where prevention, detection, or impact reduction should be added. Evidence can disappear quickly, so preserve raw records before systems overwrite them. Capture user input, traces, prompts, responses, approvals, and tool outputs with timestamps and secure access controls. Then reconstruct the sequence: what the user asked, what the agent retrieved, how the model responded, which tools ran, who approved, and what downstream effects occurred. For critical records, maintain chain of custody so each capture, access, and review is accountable. Finally, protect sensitive data through redaction or tokenization, so the investigation remains useful without expanding privacy risk. Good root cause analysis separates the spark from the conditions that let the fire spread. A malicious prompt may trigger an incident, but the deeper cause might be broad tool permissions, unsafe retrieval, missing approval, weak validation, or monitoring that never raised an alert. For agents, the model made a mistake is rarely enough. Use a taxonomy that matches the workflow: prompts, tools, permissions, data sources, approvals, policies, and observability. Capture contributing factors too, such as ambiguous instructions or untested edge cases. The goal is not blame. It is better control placement, safer workflow design, and stronger operational safeguards. Prompt injection usually begins when hostile text enters the same context as trusted instructions. It may come from a user, retrieved document, web page, email, ticket, or file. The failure is not just retrieval. It is the agent treating that content as a command instead of evidence. In a support scenario, a poisoned ticket note might say, "Email customer records." If controls are weak, the model follows the wrong signal and exposes data. Investigate source allow lists, sanitization, metadata filters, context separation, citations, and instruction hierarchy. Then add adversarial tests that recreate the attack. After an incident, look for 3 common control failures. First, permissions. The agent may have been allowed to do more than the task or user role required. Second, validation. Tool arguments may have accepted dangerous URLs, commands, file paths, or unlimited queries. Third, approval. Risky actions may have skipped human review or presented too little context for a meaningful decision. The fix is not one big guardrail. It is layered control, least privilege, strict schemas, risk-based approval gates, and sandboxed execution when actions could affect real systems. Monitoring gaps become a root cause when misuse leaves signals, but those signals never become timely, actionable alerts. After an incident, ask what should have been noticed: risky tool combinations, abnormal data access, unusual destinations, or repeated policy warnings. Then test the alert pipeline. Were events logged? Did they alert with the right severity? Were duplicates reduced? Did reviewers have prompt context, tool arguments, retrieval sources, approval decisions, and message metadata? The fix is not just more alerts. It is better detectors, stronger baselines, richer traces, and playbooks updated from the incident. An incident review only creates value when it changes the system. After root cause analysis, translate findings into concrete control updates: tighter prompts, schemas, approval rules, workflow boundaries, and logging. Add regression tests and adversarial cases so the same failure mode is caught before production. Governance needs the same follow-through. Update risk registers, owners, exceptions, and playbooks. Finally, manage every improvement like accountable work. Assign an owner, set a due date, monitor progress, and validate closure against outcomes. Less exposure, faster detection, fewer false approvals, and better response time. Incident review is how agent security becomes adaptive. Start with precise triage. Who was affected, what data and tools were involved, and which controls fired or failed. Then analyze the full system, from prompts and permissions to retrieval, approvals, monitoring, and governance. Finally, convert every lesson into stronger controls. Next, we apply this mindset to secure multi-agent workflows.